you move when we're
Describe motion. Movement?
yeah. So they're definitely movement, right?
Yeah.
We're talking about motion is movement, so that's a great example of what motion is. When we're describing motion, there's different ways that we can describe motion. And the first one we're talking about is speed. And you guys, that's how you would describe motion probably. Like if you're walking, I'd be like, oh, you're walking fast, you're walking slow. That's a speed, right? It's not necessarily a number, but it is describing it in a way that is speed. So this is our very first formula, I guess, and that's calculating speed. And you guys would do this every day when your car does it for you. When you drive a car, your speedometer tells you what your speed is. So your speedometer says that you are going so much. We always use kilometers per hour, right? We only have three of us. Thanks. Okay, it's like 15 minutes from lunch. Anyway, so yeah, we calculated our speed in kilometers per hour, but that's not necessarily the way we do it in science. We only do meters per second. But if we're talking about cars, so I'm just going to write this here. We do kilometers per hour and we do meters per second. What would they do in the States? How do they measure their speed? You know that? No? Wait, that's good. You don't have to know what they do in the States. But what they do in the States, I will tell you, because you might see it in or hear it, they measure their speed in miles per hour. So in the States, they use miles. I'm just going to write miles per hour. So there could be a question maybe somewhere that you would see it's in miles. I hope not. I would hopefully not give you one, but it's a good thing to know. If you look at the speedometer in your car, you know how there's the outside bigger numbers, those would be the kilometers. You can look at the smaller inside numbers and that'll show you your miles. So if someone said they're going like 60 miles an hour, that's actually close to like 120-ish, I think, kilometers an hour. So like you think, oh, 60, that's not very fast, but 60 miles an hour is actually like 120 kilometers an hour, roughly, okay? So like I was reading something, I always read these random dumb things on Reddit, and I was reading this thing about someone like trying to buy a car off someone and seeing if they could max out the kilometers per hour or the miles per hour. And some people, whenever you're talking to Americans on the internet or whatever, they always say miles per hour, they don't know how to convert, but the rest of the whole world uses kilometers per hour. Okay? It's just the States that uses miles. So I don't know why they don't change, but anyway. So the T on the bottom of that formula is time. So your speed is equal to your distance over your time. Your distance is kilometers, your time is hours. When we're talking about science, we might use meters and seconds. Okay? So that's meters per second. And the V, that stands for our speed, I guess, in this case. But really it's velocity. We'll look at that in a second. So on here, I didn't read what it says. It says, one way to describe the motion of an object is to compare the total distance it's traveled to the time required to travel that distance. This comparison is known as the object's average speed. What's that little triangle thing in front of the D and the T? See how it says B is equal to triangle D over triangle T? What's that triangle mean? So a triangle, if you remember, if you don't, it means delta. What does delta mean? It means a change. So delta means a change in something. So it's your change in your distance over your change in time. So if I wanted to calculate my speed right now, well, I would compare it to where I started, where it stopped. So I started. It's an average, I guess, is what I'm trying to get. I could go like this and stop for a bit, and my time's still going, and then go really fast, you know what I mean? That's how I always get to work in the morning on time. I'll like just speed really fast. But then you get to stoplights and you have to stop, so that takes away some of your average speed. I shouldn't tell you that it's speed, but I do. But you can make up time. And if you're always going at an average speed, then that's great. If you're keeping a steady speed, but often in life we don't keep a steady speed. Even when you're walking, you probably don't take a steady speed. Okay. So let's use this information to calculate or use this in a formula. So we're just using this formula that we went on the other page. So the other page said our formula is, that's not what it is. Velocity is equal to d over t. I'm going to get rid of the delta in front of it because they're only going to give us two numbers really. So for using this formula, let's read the question. It says a cyclist travels a distance of 40 kilometers. So as I read through the question, I always like to write down what they're giving us. Sometimes I will just circle it. But I would like you to, and it is good to get in the habit of writing it down. So I know you hate it, but it's a good idea. So it says we got a distance of 40 kilometers an hour. So if we look back at our formula, v is equal to d over t, which one is that? That 40 kilometers. Is it a v, a d, or a t? It's a d, it's a distance. It tells you distance is 40 kilometers. So we would go d is equal to 40 kilometers. Over a period of 2.5 hours. 2.5 hours, is that a v or a t?
T.
T? What's t stand for? Time. So we write t is equal to 2.5 hours. Now we've got our d and our t. We just need to solve for the v. So the v is what we don't know. So if we put this formula, v is equal to d over t. Let's plug in our d. Our d is 40 kilometers over time, which is 2.5 hours. Okay? So if we do that, has anyone calculated it?
16.
So how we calculate it, we take 40 divided by 2.5. 5 says we get 16. I don't really have space to write it. I'll just write it down here. V is equal to 16. Do we just write 16? What do we write? Net velocity equals 16, but that's not all we write. What's the most important? It's actually half of the marks in all physics questions. Or at least a third of the marks. The units. Even in chemistry, remember landing this morning, I was always like, you need to write the units, you need to write the units. What's the units for velocity? Kilometers an hour, and I can't fit that there. I'm going to write it up here just so it's not in the way. So our velocity is equal to 16 kilometers over hours. That looks really bad. I'm waiting on the school to get me a real Apple Pencil and a real iPad from the school. This is my own personal one. And it's also, this is not a real Apple Pencil because my iPad won't support a real Apple Pencil because it's like 2017 edition. Anyway, so yeah, it's not exact, but hopefully you can see that. My 6 looks like a B. I hate that I always write like that. But that's 16. Let's do the next one. A cheetah runs at an average speed of 80 kilometers an hour. Is that a V, a D, or a T? A cheetah runs at an average speed of 80 kilometers an hour.
T.
No? T would be a time. It does have time in it.
What's the D again? Distance.
V.
D.
V is your speed. It's a V. I guess I use them. It's an average speed, so that gives you a good indication that it is that. So for our V, I'm just going to write 80 kilometers an hour over our V. Keep reading. If the cheetah runs a period of 0.15 hours, how far does it travel? So what is 1.15 hours? Is that a distance or a time? Time, so that's our T. So I write that here. Our distance is what we don't know, right? So if we use this formula, V is equal to D over T, we're going to plug in the pieces that we know. So our V is what we know, is 80, is equal to our D, distance is what we don't know, so I'm just going to write D there, divided by our time, which is 0.15. I'm not going to write the units there because I don't want to confuse it. Okay, so how do we solve that? How do we figure this out? This is what we're doing right now. We need to figure out 80 is equal to D over 0.15. How do we get that as, how do we get the answer? Do I need to make my decimal bigger? So 80 is equal to D over, so what's our first step whenever we're solving for a missing variable, a missing thing? Cancel? Yeah, how do we do that?
We can.
Okay, we can.
We can.
You're just saying you like to cancel by dividing. So whenever we have something that's multiplying, we cancel out by dividing. But let's not confuse ourselves here. Our main purpose is that we want to move all of the numbers to one side and keep all of the letters on the other side. So what number do we want to move to the left?
Or if we want to see. And see.
Those letters. Which number? Do we want to move 80 or do we want to move 0.15? We want to move 0.15 because we want to keep D on the right and we want all the numbers on the left. So how do we get 0.15 to the left? We've got to always do the opposite to get rid of it. What's the opposite of dividing?
It's definitely not multiplying.
It's definitely multiplying. There you go. So we multiply by what?
0.15.
Yeah, 1.5. So we multiply the right side by 0.15. All right. What we do to one side, we do to the other. I really would love to have more space here. Just give me a second. Okay, I'm going to rewrite this here just so that you guys can actually see it. So what do we got? We got B is equal to D over T. In our question, we wrote our D is 80 is equal to our D we don't know, and our T is 0.15. Okay? So we want to get the 0.15 to the left-hand side. So Kai said what we do is we go multiply each side by 0.15. Because it's a balancing act. So everything we do on one side, we've got to do to the other side. Okay? You can't see that, can you? That red is awful. It looks great on my screen, but on this screen, it's good. Do you see that now? Say we multiply both sides by 0.15. So when we multiply this, that cancels out that. Alright? So then we're left with D is equal to, what's 80 times 1.15. Does that give us our answer?
It's definitely not 120.
Is that what you got to do? So that's a distance, we got 120, great, that's a great number, you got a number, but what is it? What is that number telling us? What is it, what units is it? It's a distance, so what is our units for a distance? It could be kilometers, it could be meters, you need to make sure you go back to the question. Our question is in kilometers per hour, right? So that means that our distance should be measured in kilometers. Okay. Good? Good so far? Makes sense? Okay, let's try the last one on that page. I'm gonna just bring it over to this notes section so that it's not as squished. So let's read it through. It's in a taxi taxi drives a distance of 298 kilometers. So 298 kilometers is that D, V, or T? No, it's not.
It is.
So we're looking at this number 298 kilometers. Is that a distance, a time, or a velocity?
Distance.
Distance. So we're going to write that as our D. It is 298 kilometers. Keep reading the question. So a taxi drives a distance of 298 kilometers from Calgary to Edmonton. If the taxi travels an average speed of 110 kilometers an hour, so there's another number for us. Is that our velocity or our time?
Velocity.
Are you sure?
Yeah.
How? You know.
Because it's saying about time. It just says, oh, this you went this speed.
Speed. So that's the key word there, right? Speed. So they went 110 kilometers an hour. So then the question is, how long did it take them? So that's a time, right? We're asking how long did it take? That's our question mark. So let's bring that over to the other page. The time is what we're missing. Our distance is 298 kilometers. And our velocity is, sorry, I forget already, 110. And that's kilometers an hour. So a taxi is going 110 kilometers an hour. That's good because that's the speed limit on the highway between Calgary and Edmonton. So they're not going too fast. Okay. So, what's our formula again?
V over D.
Yes. Velocity is equal to distance over time. Okay, so let's plug in the pieces we know. So we know our V is 110. It's equal to our D, which we know is 298, divided by our time, which we don't know. So we put the T there. Okay? Good so far on that? So all we've done is we took the formula, plugged in the pieces we know, and then we've got to solve for the one we don't know. We don't know what T is. So how do we figure that out? So we gotta cancel, like Kai said, we always cancel. We want to get that T off the bottom because T's on the bottom are awful. So what we do to get rid of that bottom thing is times both sides by T. I know it sounds silly, it's not a number, but that's what we're gonna use. So we would multiply both sides by T. By doing that, that'll get rid of this T. that t is gone. We've multiplied by t, so that side we're left with 298. Okay. The other side, well, we've multiplied it by t, so now we've got 110t. So now we've got still got that numbers on both sides. So we gotta get rid of the number in front of the t, because we want to know how much 1t is, not 110 t's. Right? We want to go just the time, not 110 of the time. Basically, that's what it's saying. So we need to get rid of that 110. So how do we get rid of 110? Well, we don't want this number. What is it? Is it multiplied or divided by t? What's happening there? It is divided. No. Well, we're going to divide by 110. But what I'm saying is, that is like saying 110t is like saying 110 multiplied by t. So we always do the opposite. The opposite of multiplying is dividing. So we want to get rid of that 110. What's 110 divided by 110?
Definitely not that number.
What's any number divided by itself? No. 110 divided by 110 is not 110.
It's 0.
No, it's not 0 either. Is that your answer? Yes. Yes, it is. It's 1. Anything divided by itself. 7 million divided by 7 million is still 1. The 7 million goes into 7 million one time, right? That's all it's first saying here. 110 divided into 110. So I'm saying we're getting rid of it, but really it's 1, right? We've still got 1t is equal to whatever we do one side divided into the other. So what is 298 divided by 110? $298 divided by 110. I don't have a calculator, but I'm going to guess it's somewhere in the vicinity of 2 point something. It's not? Oh, here's the calculator. Okay, so when you put that in the calculator, 298, put 298 and then put a decimal, and then divide it by 110, and it should give you an answer in a decimal. Is there any other digits?
0, 9, 0.
Okay, so I'm asking what those digits are, because we always want to round it to 2 decimal places. So this would be, if it was 2.709, we would want to round that to what? Is it 2.70 or 2.71?
0.7.
Yes. So why Kai is saying it's 2.71 is because this 9 tells us if this 9 is more than 5, then this number goes up. Up 1. Alright? So we just round that up to 2.71. It's a time, so our time is in hours. Okay? That's where we're going to end today.